direct us in a little bit. Um, but with that, I'm going to go ahead and get started. I am just be forewarned, it does appear that Google Slides is running really slowly on my computer. I have to drop out of slideshow mode and just share the slides with you all. Um, I will do that if it seems like it's too sticky to continue. So first, I want to go over our agenda for today, and I'm really going to focus on three questions along a path, and that path is data to graph to uncertainty and explaining uncertainty, and then to your takeaway story. So data to graph to uncertainty to your big picture story. And we're going to talk about three questions that every judge of a symposium or a poster session or a science research competition is going to want to know. And we're going to kind of focus those questions and then give you smaller questions that students should be asking themselves. And so the first of those questions is simply, what did you measure? And I call this the data question. This is what did you measure? And this is the data question where you will really be getting into the specifics of what were the data you collected? What do you actually have here? What are you presenting in your research? So every judge is going to want to know, what did you measure? Um, the second of the three main questions is, what did you find? And I call this the graph question because I am a strong believer in graphs, perhaps unsurprisingly, given my work at DataClassroom. But the what did you find is a central question that judges are going to want to know. And I think oftentimes that is best answered with a graph. So that is the second of the three questions. And then the third and final is, how do you know it's real? And I call this the stats question, but I don't want you to take away that this is simply, the answer to this question is simply what stats you ran or what your p-value was. But it's really a question of talking about how strong are your evidence. And we oftentimes are going to use statistics to do this, especially at the higher levels of symposiums or science research competitions. Um, and then the final thing we're going to cover today is the pre-presentation checklist. This is what I'm calling the playbook, and I've made this up into slides that I will share with you. And you can edit these if you want. If you like some things on there, but you want to add some things of your own, or you want to take away some things, you'll be able to change it. So you can kind of consider this to be a living document. But I'm going to show you what, after thinking about this for the last couple of weeks, what I include in my playbook and what would be on my presentation checklist for students. So that is our agenda for today, and I'm attempting to change slides here, but I'm having a little bit of difficulty with the Google slide right now. Give me 1 second. I am going to try one thing here. All right. Well, unfortunately, my slideshow appears to be frozen, but I have an idea here. Um, I am going to just go down to slide view here. So we will still be able to see the content. Are you all, just give me a nod if you're looking at my Google Slides now and you're seeing the slide, just not in presentation view. Yeah. Okay, great. So I am going to advance from here. So we're going to first take the three questions along the path. And again, that path is um, data to graph to uncertainty to story. And that's the way we're going to go here. Um, Along this path, let me close this up. And um, these three questions again are, what did you measure? And I think, and an understanding of and why is always important. What did you find and how do you know it's real? So what did you measure? What did you find? How do you know it's real? These are the things that anybody presenting their data is going to want to be ready to present or to speak to. And from here, oh, I apologize. This is really throwing me for a loop here where it is not advancing. Here we go. So we're on to number two, which is the first of the questions, the data question. What did you measure? And first point I want to make, and first thing I'm checking in with a student when we're talking about what did you measure, I'm wanting to know exactly what are your data. And if you've heard any data classroom webinars in the past, um, you've heard me talk about tidy data before. I can go on and do an entire 45 minutes on tidy data, but I'm not going to do that today. I just want to say this would be the first thing I would be asking a student before they're getting ready to do any kind of analysis on their project. But just, I would ask them, are your data tidy? And let them know that everything is easier if your data are tidy, where you've got each variable has its own column, every independent observation gets its own row, and you're referring to the data within those cells as the uh, the values of those variables. Um, so first question I would want to ask related to this data question, or maybe second, if the first question was, are your data tidy? This question would be, what are the variables that answer your question? And what we're really getting at is, what are the variables that you need to present? What are the variables that are going to be on X? What are the variables that are going to be on Y in your graph? What are the variables that answer your question? And this is not the same as what are all the things you collected data on, or what are all the variables you collected, but what are the variables that answer your question? Um, Next, I would also want to know, what is your sample size? And to connect this to tidy data, this is often the same thing as how many rows are in your data set. But you really want to have a good understanding of what is your sample size. It's a very basic question about your research, and it's one that I think all judges are going to be a little bit curious about when they're looking at results. It helps you put results in context. It's the first thing that tells you anything at all about the strength of the evidence. So what is your sample size is going to be an important question um, to ask a student, and an important answer for them to know. Um, And then for the what did you find, the graph question, um, we're gonna look at this and talk about, how we presented this. Did we have the right graph? Have we made all that we can of the graph? This is what we're going to look at in the graph question. So in this question, um, and I'm gonna if you guys will bear with me, I'm going to try to go to slideshow once again and see if we can get my slides to advance, because it's much nicer when we can see this in slideshow. So give me a second, and we're going to give it time to see if it has gotten um, unstuck for a bit here. Okay, so the what did you find, the graph question. Oh, this is this is unfortunate here. I'm sweating in my chair here, folks. Just working on. There we go. So, first question here. Bear with me. We have Okay. Does your graph type match your question and your variables? So this is an important question to ask. And to illustrate what I mean by this, um, if I could get my next slide. But graph type really, I always say that question determines graph type. Um, and graph type determines statistics. So this your choice of question and variables are really, really important. Here we go. And this is the slide that I was trying to bring up. So does your graph type match your question? At Data Classroom, we break questions down into one of these five major categories that you see in that little screenshot snippet of our graph wizard. And I would say 95% of research questions you can put into one of these five categories. You can talk about a question of proportions that's dealing strictly with categorical data. So we're asking, how are data distributed in these different categories? How many coin flips are heads? How many are tails? How many participants are males? How many are females? Right. So we're breaking up things into categories. These are questions of proportions, and you can see with proportions it's leading to um, different graphs there. And there are, in this little illustration, there are six different graphs there. So we're immediately, we're not in the full world of graphing possibilities, but we're working in a subset of graphing possibilities. And then likewise, those statistical tests that are listed underneath those graph types, either the chi-square goodness of fit or the chi-square test of independence, those are all things that are tied to a proportions question with categorical variables. So when we ask, do you have the right graph type? What we're really asking is, do the variables in your question, do they match the graphs that you have? And then ultimately, though, later steps, are those going to match your statistics? So the five main categories we break things up into are proportions and change over time. And change over time is really a special case of relationship, which you see relationship questions are on the end. That's when we're looking at the relationship between two numeric variables. And then the other two that are left are variability and comparing groups. With variability, we're really looking at a single variable, and the question is asking about the shape of the data and the spread of the data. Like we might be asking, are those data normally distributed? And then comparing groups, these are graphs where we're looking at numeric values in two groups or three groups or seven groups. And we're asking, are they different across the different groups? And so those are comparing groups questions. So when I'm asking a student, did you choose the right graph? We're really thinking about, okay, fundamentally, what kind of question do you have and which variables are answering those questions? Did you choose the right graph for that question and those variables? Um, my my next slide here um, is your graph design intentional? And this is something else that I've talked about in quite a few other contexts, but whether or not it's Data Classroom or any other statistical or graphing software, if you are preparing for a science research competition or a symposium, you do not want to use the default settings for the graph, right? The default settings might look okay, but you want to make specific visual choices, and you want to be able to defend, why did you make those visual choices? So these are two questions that I would ask a student about their graph. I would say, is your graph design intentional? Are the colors intentional? Is the spacing intentional? Are the size of the axis labels intentional? And then I would look at the choices they made and ask them, why did you make those visual choices? So those are things I would be asking my students every time they're going to present. I would want to know, why did you make those choices, and were those choices intentional? I want to illustrate that, and I've got an example that I like to show to look at some intentional graph design. And I'm just waiting for that to come up. Here we go. So this is a default graph. This is actually not what the default graphs look like in DataClassroom, but this is sort of what I would consider a kind of stock default graph. We've got, just a single color. We've got relatively small axis labels. I took that same data and I gave it a bit of a glow up here, where this is the exact same data that you're seeing here on the right, but the graph is quite a bit um, quicker and easier to read, right? We've done things to this graph to emphasize the message, and we've done a bunch of different things, but this graph speaks a little bit more loudly, even with the same data. And I think this is the kind of thing you want to emulate. And in the next slide, show I'm just going to show that, this was very intentional. This was not accidental to get that graph on the right. So let me just show you a summary of all of the different choices that were made and things that I did to produce that graph. So I chose the color scheme. I enlarged the data points. I removed the grid lines. I made the graph more vertical to highlight the difference in the heights of the bars there. Increased the size of the axis labels. Added the bars to highlight the measure of central tendency in each. In this case, these bars are showing the mean or the average. We've got error bars on each of those. It made the data points transparent so we can see places where we have overlapping data, where we have, more data that's hidden underneath data points. We want to show that off. We don't want to hide those data. We highlighted the labels that show the treatment groups, both on X as well as the numbers 0, 1, 2, 3, 4 on Y. Put a little caption defining error bars, and this is really important that anytime you show error bars, which should be, quite often if you have numeric data, but you should always indicate what those error bars are, right? Are they confidence intervals? Are they standard error of the mean? Are they standard deviation? Because if you have error bars without saying what they are, they're really just decorations on there. So you definitely have to define what those meanings are. The variable name that appears on the graph might not be the same variable name that's in my data set. I've chosen a very easy to understand word here, just habitat, because again, we want an uninitiated judge to gather that information and grasp it very, very quickly. So just, there's all these purple arrows are showing different things that were done to intentionally make this graph. But again, I just wanted to show that once you make, your default graph, that's definitely not the end of presenting your research in a graph. You do want to mind the aesthetics, and I really think of them as, communication enhancers, not simply just to make them pleasing to the eye, but to make the message more easily taken. And in this case, this graph, the message is that there is a difference in species richness between these two different values of the habitat treatment. And you want to make that jump off the page like it does here, where I can clearly see, bars that are two very different heights. And I can see the raw data. I can read the labels. I can tell what's going on here very, very quickly. So, then kind of some final things I would ask students about the graphing question of, the what did you find question. I would say if you're looking at your poster or you're looking at your slides, does the graph look like the most important thing in your presentation? Because I think it should be. So, is that very apparent right when you look at it? Even if you've never seen a science research poster before, you don't know what's going on, just because of the space allocated to it or the position of it, you should be able to look and say, okay, that graph is clearly a really important thing there. And then kind of as a follow-up to that, is your graph highly readable from 3 feet away? Are all the axis labels, clearly readable from 3 feet away? That doesn't necessarily mean the numbers on every tick mark need to be readable, but the label saying what is that, quantity or category that's being portrayed on X or Y, what is that? And I should be able to see it from 3 feet away, if not further. So those are questions that I'm going to ask students every time, and I'm going to want to coach my students to get in the habit of asking those questions of themselves. And when we get to the checklist, those are the kinds of things that are in there. All right, so advancing to my next slide here. Bear with me, here it comes. Okay, so last of the three questions and point number 4 in our agenda is how do you know it's real? The stats question. So again, judges are going to want to ask you, the main things they want to know is, what did you measure? What did you find? And how did you know it's real? And so to get into this question a little bit, again, we're going to go into some sub questions here. We're going to get into these stats questions when this slide comes up. Uh, but again, I do also want to say, although I've nicknamed this the stats question, um, this is not purely statistics, right? We're also saying when you look at the data, um, how do you know it's real? Um, and so one of the ways you can assess whether a result is real or not is asking yourself the question of, do I show the variation um, in my data, right? Do I show the variation in my data? And this is an example of a graph that's showing the variation in the data. And I want to say that this is showing variation two ways. One, you can see the cluster of data points, and so you can quite literally see the variation in the data that were collected in each group. So this was actually agricultural data where we had trees of different age groups. And so some trees were 6 years old, another group of trees was 18 years old, another group of trees was 30 years old. And we were measuring the total sugar in the fruit of those trees. These were actually mango trees in India. Um, but in this, if this was my visualization, I would be able to say, yes, it does show the variation. It shows it two ways. One, it shows it with the cluster of the data, and two, it shows it with the error bars that are around the edge of the bar, showing the 95% confidence interval. So, together, these are giving me an indication of, not only the variation, but also the amount of confidence I have in those estimates of the mean. And then we're able to compare it across groups. So this is a very transparent presentation of the data where all of the variation are clear. What you don't want a judge to be wondering is looking at your data, and probably the worst offense of this is if you're showing a graph where you have 3 bars and you have no raw data and you have no error bars, where the bars represent the average, but the judge has no idea what is the sample size that went into these, where do the data points actually fall around those bars, or how confident am I that those bars indicate a true mean. So I would say with numeric data, you almost never want to see a mean bar that doesn't show some measure of variance, whether it's the data points themselves or it's error bars. But that's just kind of simply not a graph you want to use to present your numeric data there. Um, Going on to my next slide here. And the next we're going to talk about the stats tests again. And this is the way that I think is most common for a judge to ask about your statistics, right? They're not going to ask you what your p-value is because you probably have already presented that clearly on your slide or in your poster or even in your verbal presentation. But they might ask, they might say something like, "Hey, I see that you did a t-test there. Why did you choose that test?" Or "I see you did a chi-square, or I see you did an ANOVA. Why did you choose that test?" And I think for any of these stats tests, it comes down to just kind of a very simple algorithm that's based on what kind of variables you had for a given test. And so, for example, I'll take each of these kind of one at a time for each of these of sort of what I think would be a quick, snappy answer to that question of why did you choose that stats test, right? Well, if I chose ANOVA, I would say, well, I chose ANOVA because I was comparing the average sugar content across three different groups, right? So you've indicated, an ANOVA is a fit when you've got more than three groups. I've got average sugar content there, or total sugar was a numeric variable, so that's why I chose an ANOVA there because I had three groups and I was comparing a number, right? With t-test, I'm comparing this mean running cadence in this example. Again, the data is not so important here, but the answer to that would be, well, I chose that test because I had two groups and I was comparing the average value of mean cadence, right? So I've got a number, I'm comparing it across two groups. For chi-square, in that example, why did you use a chi-square? Well, I was just analyzing a single variable. It was categorical, and I wanted to know if, the distribution of those categories was different from a null hypothesis. And I don't know what the null hypothesis was in this. It could be, I could have predicted that red brocket deer would have four times as many observations. I don't know. Or, as a default expectation, we could have just been testing whether these, differed than we would expect due to random chance alone. But I used a chi-square because I had all categorical data and I was testing against a null expectation of, and you can fill in the blank there, right? And then for linear regression, quite simply, I used a linear regression because I was testing for a relationship between Raptor offense and Raptor total. Both were numeric variables, right? So anything that speaks to, I was testing for a relationship between two numeric variables. So no matter what the answer is to that question of why did you choose that stats test, it's related to the kinds of variables you have, um, and what your sort of central question is. Are the groups different from one another? Is the distribution different than a null? Is there a relationship? And when you're working with DataClassroom, that information is going to pop up for students as they're doing the analysis, and that's a good time for them to do some note taking or start committing that to memory. But if you're using some other tool that's not explaining those things, those are still things your student is going to want to look up, and they're going to want to be ready to answer that question of why did you choose that stats test. And then going along with that, and I think this still very much goes with the graphs, but I want to know, can you honestly discuss the strength and weakness of your evidence? And hopefully you can do both. But if your data are overwhelmingly strong or overwhelmingly weak, maybe you're really just discussing one or the other. But in most cases, hopefully you're discussing both. So, you're wanting to discuss the overlap you're seeing in the range of the data if it's numeric. You're wanting to discuss, any weakness of your design, but you're wanting to, acknowledge that before the judges do. So you're going to want to be familiar with your data and familiar what the critiques of your data would be. I will say one of the best ways for a student to obtain a kind of comfort in discussing the strengths and weakness of their data as evidence is to do some practice presentations with knowledgeable people who can kind of poke holes in what they've said. But they should also, use what they know about the scientific process to look for weaknesses in their data and try to anticipate and be ready to talk about those things, right? And particularly if they get a result that doesn't support their hypothesis, they're going to have to decide whether they completely lean into that and say I take this as evidence that there is no difference between groups or there is no relationship, and I think my hypothesis was not supported, versus an alternative of this is suggestive. It looks like there may be a difference, but my sample size was only 6 in each group or something, right? So that, and having some kind of comfort and nuance with their data to be able to talk about it in that way can be important. Okay, so finally, um, we have arrived at the pre-presentation checklist, and I'm not going to go through this um, and sort of read everything, but what I've done is I've put together a checklist that will kind of compress all of what I've just summarized here in the presentation today, and you can use this with your students if you have questions and comments. We can definitely discuss those, and I would welcome a discussion here. Yes, Crystal in the chat, you will definitely get a copy of this presentation if you registered for this. So all of you here have registered for this. You will get this in your email. Well, you'll get all of the slides today, including this pre-presentation checklist. And let me just see if I can show you this. For a second. So we'll call this the pre-competition data checklist. These are things that you want to think about before you talk about your data with the judge. So, question number one, what did it measure? We're looking at things like, is the data tidy? Is your final data set ready for analysis? Is each data point independent? And do you know your sample size? So that's what we're looking for in the what did you measure? What did you find? Does the graph type match your variables? Does your graph show variation? Is your graph design intentional and readable from more than 3 feet away? And this is checklist again. This is for your students to use. How do you know it's real? Do you have error bars on there? If it's categorical data, do you have your sample size on there? Do your stats match your graph? And can you talk about the strengths and weakness? So that's kind of a checklist of what I summarized for you all today. Also, want to just put up this like 10-second walk by test. Is your main figure big? Can you see the main result in 10 seconds? Have you trimmed your methods down sufficiently and given the rest of the space to your graph? And does your poster somewhat read without you standing next to it? So I think all of that, can be part and parcel of your test there. I want to put up here, this is my contact information. So again, I'll email you all of these resources, but if you have any questions at all, if you want to discuss anything, please don't hesitate to reach out to me. I've also put a QR code on there for a 60-day free trial of Data Classroom tools